The next video is to explain how to do Unit 5, Momentum. The first goal is to figure out how to find momentum. You have to remember that P is the letter for momentum, M is mass, and V is speed or velocity. So the first one you have to do is basically solve for momentum and then rank them highest to lowest. So if we use that equation, m times v, the mass for the first one would be 1 kilogram, moving at a speed of 40, which gives us 40, and the units would be kilograms times meters per second. The second one, the mass is 16 times 3, so 16 times 3 is 48, same units. And the third one is 50 is his mass times 1, so that would be 50 kilograms. So you would rank them. The biggest one would be 50, so highest. The next one would be B, and the lowest would be C. The next goal is to quantify how changes in mass and velocity affect momentum. So all of this is still related to this equation. You have to really look at it to answer some of these questions. So if two objects are moving with the same velocity, the one with the greater blank would have greater momentum. So to get a bigger value for P, if this is the same, then the one with the bigger mass will have a bigger momentum. If two objects have the same mass, then the object with the greater velocity will have greater momentum. The next one, we're going to use the impulse formula, and the impulse formula is impulse equals force times time. So if a watermelon is dropped out the window and hits the sidewalk with a force of 10 newtons, that's going to go in here for my force, and it takes 0.1 seconds to stop. So 0.1 seconds gets plugged in for time. When I multiply them together, I just move the decimal over one place to the right. It turns out the impulse would be 1, and the units are usually Newton seconds. So I have this looks funny. I typed it funny, or it didn't print out right, but the correct answer would be B. If we dropped another watermelon off a high dive into a swimming pool, it's going to hit with a force of 10 newtons, but it's going to take longer to stop. So if the force times time, if the force is now 10 newtons, same as it was before, but it takes 3 seconds to stop, I'm going to change that to 3. What's the impulse? The impulse would be 30 newton seconds. So that would be C. Moving on to goal 5, they want you to fill in the following table. So the following table has force and time, and you multiply them together because impulse is force times time. So 100 times 1 is 100. 25 times what would give you 100? 4. Basically take 100 divided by 25. 100 divided by 4 gives you 25. 100 divided by 50 gives you 2. 100 divided by 1 gives you 100. So using the table above, you can say the greater time it takes for an impulse to occur. So when we look down the column, greater times, 1, 4, 25, 50, 100, they want to know what happens to the force. So as the time increases, the force goes down. So the force acting on the object is less. In other words, when talking about impulse, time and force are inversely related, because as time goes down, the way we did it is time goes up, force goes down. So we got the opposite arrows, so we know that's inverse. The next one is stating the law of conservation of momentum and understanding how that works. So the law of conservation of momentum is that the momentum before a collision is going to equal the momentum after a collision. So that's important because we're going to learn that as you look at collisions, that's important to keep in straight. So basically, we could shorten this up and say the momentum before a collision equals the momentum after the collision. There's one important comment on this, and this is only true for a system. Okay? This is important. If we look at A, B, and a spring, the entire thing is considered a system. So if we look at it right now, the momentum before the collision, or in this case it's kind of an explosion, the momentum before the explosion is going to be 0 because there's no velocity if those blocks are sitting at rest. So what we're saying is the momentum before the explosion will be 0, and the momentum of the system after will also be 0. That's what the law of conservation of momentum states. So if we figure out why, well, if you look at them, A and B are probably going to go different speeds because B is more massive, so it's going to go a little slower, but it's going to the right, A is going to the left, and so it's going to be negative. So it's going to be, it's smaller mass, but it's going to have a greater velocity. So we could kind of think of it like this. The mass of A is little, but it'll have a big velocity. It's going to equal the bigger mass of B's little velocity. So you're going to have the same value before that you do after. They're actually going to cancel each other out because if you added them up, they would be, the fact that A is negative will cancel out and go to 0. So in the momentum of objects A and B will change, but the momentum of the system won't change. So what they mean by that is, hey, if we think about A only, okay, it starts at rest, right? So 0 momentum. But after it's released, it's going to be, it has momentum. It's going to have moment because it's got, it has a mass, and it's going to have a velocity, so it's going to have a momentum. So if you considered A only, it would not be the same before and after, okay? If you considered B only, it would be different before and after, because it's 0 before, but it would have momentum after. But if you consider them both together, the momentum of the system will be 0. Goal 5.7 is looking at using this conservation of momentum to determine the final velocity of a system after the collision. So for this, you need the big equations. One of them is for sticky, and one of them is for bouncy collisions. All of them, both of them, have the same formula on the left side. So before the collision or the explosion, whatever is happening, the mass of one object times the velocity of one object plus the mass of the second object times the velocity of the second object will equal. And then if it's a sticky collision where two objects connect together and have one velocity, what will happen is the equation will look like this. The final velocity is the same for both, but M1 and M2 have to be added together. So if we look at this problem, a 40-kilogram girl is standing on a skateboard. Someone throws a 10-kilogram backpack at her with a given speed. What speed will the girl go on the skateboard with her backpack in her hand? So they're going at the same speed. So we're going to use this equation, and what we're going to do is we're going to take each number and just decide where we're going to plug it in. So we can call the girl mass 1, so we'll plug it in there. But if she's standing on an unmoving skateboard, then her velocity is 0. So that part's going to drop out. The backpack is 10 kilograms, and it's moving at a velocity of 40. So that is not going to drop out. When you multiply that together, the left side of the equation is going to be 40. The final velocity is our unknown, what we're looking for, but we can look at our masses. Mass 1 is 40, mass 2 is 10, so we add those up. And what we have is an algebra problem where we're just going to take and divide by 50 to solve, and we'll have the final velocity is 0.8 meters per second. Now, the other equation we're going to use is if you do not have them sticking together. And basically, it's going to be this equation with exactly the same thing on the other side. So I'm just going to write it out here. m1v1 plus m2v2, that would be the before, equals the mass of the same mass, m1, but it's going to have a new velocity. We usually put a little prime sign by it, plus m2v2 prime. So let's call this one the ball. So a 7.5 kilogram bowling ball, call that mass 1, is thrown down a bowling alley at 9 meters per second. Plus, it hits a bowling pin, which is 2.5 kilograms. That's M2. But if you know anything about bowling, you know that the pins are at rest at the beginning. They're just sitting there, so that's going to be 0 speed. We're going to use the same M1, 7.5. And then, how do you figure out what velocity is given to you? You have to be careful and read. So after the collision, it says the pin flies away with a velocity of 11. So I have to make sure I keep that 11 by the pin's mass. And remember, the mass was 2.5 kilograms. So that 11 has to go with M2. So I'm going to rewrite my mass 2 as 2.5, and I'm going to put my 11 in here as the speed, the new speed of the pin. Bring down your plus, and then you can see, hey, what's the velocity of the bowling ball? So this is my unknown, what I'm looking for. So now I just have to use a little algebra. 7.5 times 9 turns out to be, let's see if I have this already solved, 67.5. And that equals, I can't cancel anything out yet here, but I can multiply the, oops, that's a plus, multiply these guys together, which turns out to be 27.5. So if this is being added, the next algebra step is to subtract it from both sides. When I do that, it disappears over here, right? 0. This becomes 0, 0, 40. So 40 equals 7.5 times my unknown. So I'm going to divide by 7.5. 40 divided by 7.5 turns out to be 5.3. So the new speed of the bowling ball would be 5.3 meters per second. The last goal